Hi class. In this lecture, I would like to talk about the dual and minimizing problems. Keys of this lesson is to know the basic concepts of the dual of the LP. We start from the very beginning example, the farmer Brown. Farmer Brown is planning his planting for the coming year. He expects to raise 2 crops, potatoes and wheat. He has 100 acres of land available for planting and will be able to devote 160 days of labor to his crop. He expects an acre of wheat to require 4 days of labor, while an acre of potatoes require only 1 day. He has $1,100 that he can use for startup costs. Of planting and cultivating, it costs $10 an acre to plant and cultivate potatoes, while the corresponding cost for an acre of wheat are $20. If Brown expects a revenue of $40 per acre for potatoes and $120 an acre for wheat, how many acres of each should be planted in order to achieve the maximum possible revenue? So this problem is the very beginning example that we are learning the LP models and use this example many times for gas modeling and so on. And now I will use the same example to show the basic concept of the dual of LP. This is the original model. Maximize Z equals to 40 times x1 plus 120 x2. x1 plus x2 less or equal than 100. x1 plus 4x2 is less or equal to 160. 10x1 plus 20x2 is less or equal to 1100. Okay, so now we have new scenario. In the problem, we have 3 resources, include acres of land, days of labor, and capital. And let Farmer Brown ability to sell excess resources or buy additional resource if needed. So we will introduce a new decision variable that is the price per unit for buying or selling the resource. So y1 represents buying or selling acres of that. y2 is representing buying or selling days of labor. And the y3 represents buying or selling capital. Before we continue, we need to have some assumption for this problem. In this problem is perfect competition, which means no external force will influence the situation. The market is totally in autonomy, in perfect competition. Okay, so if a firm makes a return in excess of the value of resource needed and another firm enters the market at a low level of return and drive the price down, the result is that the market seeks to force the profits to zero. The situation is described as malevolent market. Okay, so this is the 2 assumption for this problem to explain the dual. So the new profit for the Farmer Brown is, this one is the original profit, and this one is price. This one is the excess of the land. And this one is for the labor day, and this one is excess of labor day. And this one is the capital, right? So total profits included two parts. One is the profits comes from planting the crops. Others are through sale or buying assets. Okay, so if this number 100 minus x1, x2 less than 0, or which means here less than 0, so it become minus, right? Or this one is less than 0. Okay, so original profit will become less. So Farmer Brown will lose his profit. And use the malevolent market, right? So we'll try to make the price y1, y2, or y3 become to 0. Okay. So we put all the value together. Okay. So the profit will become the x1, x2, and here is the coefficient, right? And here is the profit not related to x1 and x2. Okay. So the coefficient of x1 and x2 represent opportunity cost for Brown. Okay. To participate in the market by producing crops, right? So here is the coefficient. Original is 40, but now because it can sell or buy in, so it will not become a fixed coefficient. Okay. So if the coefficient is positive, then Brown makes arbitrarily large profit by producing crop at any level he chooses, right? If this number is positive, then we always can produce more to earn the money. Okay. So in this way, it will become unbounded. So we try to set the coefficient become non-positive, which means it's less than 0. Okay. So so these two number under the assumption, it will become the new constraint here for y. Okay, so the new one, the constraint will be the here for the resource or assets. Okay, and also market is trying to make the profit tend to 0. Okay, then x1 and x2 in the objective will be the 0. So finally, all of this one and this one, right, will become the 0. So profit will become 100 y1 plus 160 y2 plus 1100 y3. Okay. So now we'll try to get the dual formulation, because now the market will try to make this profit tend to smaller. Okay, so the direction of the objective W become to the minimize, and two of the constraint comes from the opportunity cost is non-positive. Okay. So the profit can in terms of x and in terms of y, right? Basically, according to different point of view, then you will have a different profit. You can either see the original, we call the primal formulation, or you can see from the dual, so it's a dual formulation. Okay, so here there is a new term called complementary slackness. Okay, so according to the assumption already explained, then we will know the coefficient times y or the coefficient times x should be 0. Okay, so we say that when y equals to the y1 hat, y2 equals y2 hat, and y3 equals to y3 hat, x1 equal to x1 hat, and x2 equal to x2 hat in an optimum, then we say that z equal to w. Okay, so for the general form of LP will be this. In the previous, this slide shows that two variables, but now we extend the LP to more general. Okay, so the primal, if the primal is minimization W, C1Y1 till CNYM, and subject to here, and the dual would be maximization, and in this form. Okay, before the lecture, we always talk about the maximization as a primal, then minimization will be the dual. So the relation between these two are primal and dual relationship between to each other. One can be a primal, the other will be the dual. Okay. So what is the principle for transform the minimization primal to dual for maximization problem? There are 7 principles. The first one is transpose the matrix of coefficients. The right-hand sides of the constraint become the coefficient in objective function. Third, the coefficient in objective function become the right-hand sides of the constraint. The number of the variable become the number of constraint and vice versa. The direction of the inequality are reserved. The objective of minimizing becomes one of maximizing and the vice versa. And 7, the variables of both problems are non-negative. Okay, so here is an example. Okay, so we start from the minimization problem here. Then, according to the 7 principle, we will see here the right hand side become the dual here, right? Variable here. See? And the objective here become the right hand side, right? Okay, and the coefficient here become the coefficient here, coefficient here become here, which is the transpose of the matrix, right? And this example shows the principle of the 7 items, how transfer the primal to the dual. Okay, so we'll see again. Okay, again. So, hope you already know the basic concepts of the dual formulation comes from the economy point of view to explain what is the dual and how they can explain by selling or buying assets. Okay, so hope you feel comfortable in this way, later on I will talk more about duals in the following lectures. Okay, see you. Bye bye.